How is lunar regolith used for building moon bases? Imagine a world where the very ground beneath your feet helps build your home. On the moon, that ground is called lunar regolith, a layer of loose dust and broken rocks covering the surface. This material is a treasure for future moon bases because bringing building supplies from Earth is extremely expensive and slow. Using lunar regolith directly means we can create habitats and structures right on the moon, saving time and money. There are four main ways scientists turn lunar regolith into usable building materials. The first is reaction solidification. This method mixes regolith with chemicals brought from Earth, which bond the particles together. The result is similar to concrete, with about 60 to 95% of the final material made from lunar soil. These solid blocks are strong and durable, perfect for walls or floors. But since it needs chemicals from Earth, it still depends on supply missions. The second method is sintering or melting. Here, regolith is heated to just below its melting point, often over 1000 degrees Celsius, so the particles fuse without fully liquefying. Microwave sintering is a promising technique that uses focused energy to do this efficiently. This method creates solid structures entirely from lunar material and can produce things like habitat walls or landing pads. It requires a lot of energy and specialized equipment to handle the high temperatures safely. The third way is bonding solidification. This technique uses binders, materials that stick regolith particles together, at lower temperatures than melting. It produces strong materials with about 65 to 95% lunar soil content. This process is faster and safer than sintering but still needs some chemicals from Earth, like glue for the soil. The last method is confinement formation. In this approach, regolith is packed into fabric containers or bags without any chemical or thermal bonding. It can use up to 99% lunar material and needs minimal processing. These packed bags can be stacked to from walls or barriers, acting as shields against radiation and micrometeorites. In practice, lunar regolith can be processed into a material called lunarcrete, similar to concrete, which can be used with 3D printers. Robots or astronauts prepare the site by clearing debris and leveling the ground. Then, 3D printers mix regolith with binders or use sintering to build habitat walls layer by layer. Thick layers of regolith can also be placed on top of structures to protect inhabitants from solar radiation and space debris. Before starting construction, detailed analysis of the regolith's properties is essential to ensure stability. Engineers use digital maps to plan the layout of the base, choosing zones for landing, manufacturing, research, and living spaces. All these steps depend heavily on excavating, compacting, and transporting lunar soil. Using lunar regolith for building reduces the need to send materials from Earth, cutting costs and making long-term human presence on the moon possible. It turns the moon's surface into a resource, helping us create sustainable habitats and infrastructure for future explorers.